Now let's see, build linear models from verbal descriptions. Modeling with linear function, we use slope-intercept form f of x equals mx plus b, where m is the slope of the line and b is the y-intercept. So now let's look at the example. Straight line depreciation. Book value is the value of an asset that a company uses to create its balance sheet. Some companies depreciate assets using straight line depreciation so that the value of the assets declines by a fixed amount each year. The amount of decline depends on the useful life that the company assigns to the assets. Suppose a company just purchased a fleet of new cars for its sales force at a cost of $31,500 per year. The company chooses to depreciate each vehicle using the straight line method over 7 years. This means that each car will depreciate by $4,500 per year. All right, that's the verbal description about this scenario. And then ask you to answer the following questions. First, write a linear function that expresses the book value V of each car as a function of its age, which is independent variable x in years. Okay, let's do the A first, and then we look at others. So the key word, okay, I'm already marked in red, straight line depreciation. So straight line tells us the function is linear function, right? Because only linear function, the graph, is a straight line. Okay, so once you see straight line or the keyword linear, right away you can write a function f of x equals mx plus b. And then another keyword, say depreciation. Depreciation, that means decline, right? So that indicates slope is a negative number. Is that right? It's a negative number. So how much is depreciated each year? $4,500 per year. So we know slope should equals negative $4,500. All right. So we have the slope. Now we're looking for the y-intercepts. What is the y-intercept? That means when x equals 0, right? When it's new, so the age is, what's the x, right? Age is what x stands for. So when car is brand new, and then what is purchase value? That is the y-intercept. So the question is also given us b equals 31,500. Okay, so after we identify these two parameters, we can just update the function and we can easily write a model, right? Now the f of x, we use v of x represent, right? Book value. V of x equals negative 4,500x plus 31,500. Okay, that's the model, linear model to describe this problem. Graph the linear function. So we want to graph, we already know the y-intercept, which is 0, 31, 500. Okay, so we can use the y-intercept and the slope to do the graph, right? And also we can use the x-intercept to graph. So if we let v equals 0, can we solve for the x? 31,500. Okay, let's try 31,500 divided by 4,500. We got a 7. Okay, we solve x equals 7. So that means in 7 years, the book value will be decreased to 0. And then we can use this xy intercept to do the graph. Excuse me. So 31,500 500 is about here. This is a age, okay, x in the unit of years. So connect these 2 points. Okay, we can get a line. And then answer the question C. What is the book value of each car after 3 years? So that means when x equals 3, okay, plug in x by 3 and then evaluate the book value. So V3, that's equals -4,500 times 3 plus 31,500. That's equals what? Let's use calculator to quickly calculate it, okay? $4,500 times 3. So I got 18,000. 18K. So the book value for each car after 3 years is $18,000. Okay, interpret slope. Actually, here is already interpreted. So the book value, okay, for each vehicle depreciate $4,500 per year. When will the book value of each car be 9,000? Okay, so replace V by 9,000 and then solve for the x. Okay, so I put in here no space. So 9,000 equals negative 4,500 x plus 31,500. So we got a 4,500 x equals 31,500 minus 9,000. Got a 225,000. So we solve x equals 5. So after 5 years, the book value of each car will be $5,000. Okay, that's how we solve this word problem using linear model. So the next few slides, it shows the detail, okay, of how each question can be answered and calculated. And then the better graph, okay, my hand graph is not accurate. This is a more accurate graph for this problem.